All right, so I'd like to say thank you everyone for coming. My name is Cody Armstrong, and today we're going to focus on sketching basics. We're going to get into the details of sketching, try and walk through each of the sketch tools, a number of the different relations or constraints that are there, and all the different sketch options that we have. So really going to focus on kind of the basics of sketching. Really intended for those that maybe are just getting started with Onshape, maybe have some sketch background, maybe no sketch background at all, no background in maybe AutoCAD or SolidWorks or something to that effect. So just getting started with Onshape, trying to get a grasp on all the different sketch tools. So as I always say with these webinars, we really encourage you to ask any questions that you have. So feel free to type in the question in the questions dialog in your GoToWebinar control panel. I'll do my best to stop and answer them from time to time. So again, feel free to type in anything that you'd like. I'll do my best to stop and address it. If I don't get to your question, feel free to stick around and I'll make sure to answer any of them after the webinar is over. As I always say with these webinars, again, there are a few things that I like to point out about Onshape in general, especially for those, if this is your first webinar, some things I always like to point out about Onshape. And the first is our mission statement, and that is getting everyone working together with CAD on any device, anywhere. And this includes mobile devices and just about any, operating system, Linux, Mac, Windows, Chromebooks even. So if you haven't downloaded the Onshape app, and if you haven't tried using Onshape on another computer, just realize that you have accessibility. You can get to your data from anywhere. And our mobile apps are full-blown CAD editing tools. They're not just viewers. So you can create parts, you can build assemblies from your phone or from your tablet. So everyone working together with CAD on any device, anywhere, that's our goal. Now, some other things I always like to point out, we do consider ourselves professional 3D CAD, and we do have all three major pieces of professional 3D CAD: parts, assemblies, and of course drawings. Some things that are unique about Onshape is that we evolve very quickly. You're going to see updates to Onshape roughly every 3 weeks with new functionality being added. The neat thing about it is it doesn't take anything from you. You don't have to do anything. The next time you log in, it's there. So constantly evolving, moving very quickly. And in terms of work on the end user, there's none, right? It's just new functionality being added. Some other things I like to point out, with Onshape you get built-in version control. This means that you don't have to manage versions using a separate application. Right? It's not something that you have to manage separately. Also, for those users that are coming from another CAD system, we can read and write common CAD formats that are out there. So Step, IGES, Parasolid, also some native formats like Inventor, SolidWorks, and so on. So a lot of different formats to both import and export. So definitely worth checking us out if you're looking for a tool maybe to work alongside your CAD system, or maybe just Onshape as a tool to share your models with vendors. So read and write common CAD formats. Also, the last thing I want to mention is entirely new methods of collaboration. So if you haven't shared a document in Onshape yet, I definitely recommend it. You can collaborate in real time with other users. I can comment and chat inside of a document. I can even see each other's screen in real time with follow mode. So there's all kinds of neat collaboration tools built into Onshape that are definitely worth exploring. So question that's popped up: when are you going to have CAM? One thing that we've recently announced is the Onshape App Store. We do have a couple of CAM solutions in there. There will be more as well. If you haven't checked out the Onshape App Store, it's definitely worth doing so. There's a link to it at the documents page. Visual Cam, Master Cam, CamWorks are three examples that are listed in there. They all have either a connection to Onshape, or in this case, they're all connected or able to connect to Onshape. So we will have more CAM solutions. We'll have more render solutions. We'll have more finite element analysis solutions. So the Onshape App Store just announced, and a lot more to come. So, all right. So what we're going to talk about today is really the basics of sketching and an introduction to sketching, and that's really the way to think of it. We're going to walk through each one of the different sketch tools, going through creating constraints, a number of different sketch bits and functionality that we're going to cover here today. So intro to sketching is really the way to think of it. A crash course in sketching is the way to think of it. We're going to really focus on all the tools in the sketch toolbar, also a bit on relations and creating planes. So I want to spend just a bit of time on creating planes as well. Now, throughout this, I have just a few miscellaneous tips and tricks I always like to show new users that can be helpful as you're just getting started. So that's really the goal. Now, why is this so important? That really, the sketching is the core of everything that you do in a 3D model. So in a system like Onshape, it's all based off of the sketch geometry and how it's constructed. So a lot goes into the design intent and how we construct a sketch in Onshape. So sketching is the core of everything you do, and it's defined using a combination of dimensions and constraints, which we're going to cover in just a bit. It's not just solely dimensions. Constraints play a large part in how we define our sketches as well. If you have prior CAD experience, if you have experience with traditional CAD systems, a lot of this should be very familiar. So similar to traditional CAD applications that are out there. Okay, so as I mentioned before, we're going to jump right into things, and I'm going to jump right into a document. Now, again, we're going to start with the basics. So just assuming that you really don't have, maybe a lot of background in CAD or a lot of background in sketching. A lot of what I'm going to cover here today might be redundant, even for those users with no Onshape background but heavy CAD background. A lot of what we've done in Onshape carries over from traditional CAD in terms of behavior and things. All right, so let's get started. Now, one of the first things is you're just getting started, your first document. I'm ready to start my first sketch. The question often comes up, well, how do I define what plane I want to put my first sketch on? How should I decide whether it should go front, top, or right? And that's the important thing to realize when you're first starting. You need to define a plane. And so the question often comes up, well, should I choose front, top, or right? Does it really make a big difference? And the answer is it doesn't make a huge difference. There is one thing to consider with that, and that is the front plane will correspond with the front view of your drawing. So if you like the front view of your drawing looking a certain way, make sure that aligns with the front plane. That's really the only consideration I would give, whether or not you choose the front, top, or right. There are a lot out there that have their, I always choose this or that. It depends on this or that. But I'd say probably the biggest consideration is, what do you want the front view of your drawing to look like? But again, don't spend too much time in it. Just choose one and get started. Now, the key thing is selecting it. How do I tell it this is the plane I want to choose for my sketch? And the easy way is to just pre-select it, to select it first before starting the sketch. So in my case, let's say I wanted to start a sketch on the front plane. You'll notice as I mouse over it, it highlights. I left click, and then I click sketch. Some things to notice. Now that I'm in a sketch, notice that I have a sketch dialog here. Right? It tells me the sketch name, the plane that it's on. I also have this option to show the constraints. So just some visual cues that you're in a sketch, an important thing to note. Also notice the toolbars changed. So now I have sketch tools instead of course, feature tools, which were there just a moment ago. So now I can start sketching. Now, one important step before I actually start selecting tools and actually drawing in sketch geometry is a command we call view normal to sketch plane. Right now, you'll notice that the front plane, I'm not looking directly at it. I'm not perpendicular to it, so to speak. So that's what we refer to as normal to the sketch plane. Now, there's a number of ways you could do this, but one of my favorites, one of the ones that I like to point out to a new user, is the right-click menu. If you right-click anywhere in graphic space, you'll see this View Normal to Sketch Plane. And probably one of the biggest tips I can give a new user is that right-click menu. It's useful in a number of situations, not just sketching, but features and assemblies and even drawings. The right-click menu is a valuable one in Onshape. So right-click menu, View Normal to Sketch Plane. And so that often means that starting a sketch is 3 steps. I select the plane or face, right? I select sketch, and then I view normal to sketch plane. That's pretty standard for almost every sketch that you're going to do. So now I want to start sketching. And again, notice that the sketch tools are there. I don't have features. I have, lines, rectangles, circles. I'm going to walk through each one of the different sketch tools in as many relations as I can. We're going to start with the simplest one, and that is, of course, a line. Now, before I get into too great a detail on each one of these, I do want to point out that they do have submenus. So just keep that in mind. We do have variations on a circle, variations on an arc, polygons, for example. So just keep it out. If you see a drop-down menu, there are other options. But starting with a simple line, I select line from the toolbar. You'll notice that the cursor changes to a black crosshair instead of being a cursor, like an arrow or a selection cursor. So you get the visual feedback that you're in a sketch tool, right? And as I move my cursor around on the graphics, you'll actually get these cues, these little inferences to the origin, right? So as I move my cursor around, you'll see a horizontal there, vertical there. So I'm getting visual feedback that I'm creating a constraint relative to the origin, right? So you get the visual feedback there. Now, if I want to draw a line, there's actually two methods to drawing a line. The first is the simplest and probably the most commonly used, and that's just 2 clicks, 2 left clicks. So I left click, move my cursor, left click again, and I have a line. Now, the advantage or disadvantage, depending on how you view it, is that it defaults to another line. It assumes that you want to draw another line if you do 2 left clicks, right? So if you want to draw multiple lines, that's definitely the technique that you're going to use. But if I want to draw one simple line, then you'd use the other technique. Now, just an aside here, I have this line, I don't want it, right? I'm currently in the construction of it. I can use the escape key to escape out of a tool. So an important tip is the escape key that will exit whatever sketch tool you happen to have up, right? So there's my first line, 2 left clicks. Now I mentioned before there's another method. Let's do that again. Line. This time instead of 2 left clicks, I'll left click, hold it down, drag, and let go. You get the same thing, a line, but notice it does not default to drawing another line. So again, same end result. You're essentially just drawing a line, but you can do 2 left clicks or a left click and drag, and you get the same thing. The main difference is the behavior afterwards, right? One assumes that you want to continue drawing lines, the other doesn't. All right, so another tip, I've drawn this, these lines in space. I don't really want them. I realized I was just playing around, or they're there, by mistake. How do I delete things from the sketch? And you can do it a few different ways. You can left click individual lines, points, circles, whatever it is, and select delete on the keyboard. That's the obvious approach. However, if you want to get rid of a whole bunch of sketch geometry at once, left-clicking individual sketch entities is not ideal. You can window select, and that's a left-click drag over the geometry. Okay, so you can window select and delete sketch geometry that way as well. Okay. So just a tip, especially as you're just getting started, you will need to delete occasionally. Select the entity, hit delete key, and it disappears. So that is the lines. Again, 2 different methods. The next one in my list is rectangles, and we have 2 different types. And again, you get the same exact geometry. It just depends really how you want it to sketch it and how you want it constrained. So we have a corner rectangle and a center point rectangle. Let's start with the corner rectangle. I'm going to move my cursor down over the origin. Notice there's a little white flag next to the cursor. As I move my cursor near the origin, I get the vertical flag appear. If I move it over the origin, I get the coincident constraint. So it's giving me visual cues that it's going to create a constraint. So I'll left click. Okay, now I've defined the first corner. Move up, down, left, or right, depending on the orientation that I'd like my rectangle, and left click again. Simple corner rectangle. Again, the idea behind it is corner to corner. So you're by each click, you're identifying a corner of the rectangle. Now, a commonly asked question is, can I define the size as I'm sketching? And the answer is absolutely. You may have noticed these little numbers that appear as I'm sketching in Onshape, and those numbers, newly added as of just last week, I believe now, allow you to enter values as you're sketching. So I can sketch a rectangle, enter 5, and that adds a dimension and defines the sketch. So I can very quickly add sketch dimensions if that's the the workflow that I like. So just a commonly asked question, can you add dimensions as you're sketching? And the answer is yes. You'll see them appear. Just enter a value, enter, and it defines it. Okay, so that is a corner rectangle. Again, I'll do the window select and delete. We'll do one more, this time a center point rectangle. The only difference here is, of course, how it's defined. So instead of being from corner to corner, it's from the center point. In this case, I'll put the center point right on the origin, and it moves in equal directions, any direction I move my cursor. Okay. So again, the main difference here is if you need to identify the center of a rectangle, this is definitely the tool you want to use. It gives you a point that you can reference and attach to other things. Okay. So that is a center point rectangle, very similar. The only difference is, of course, how it's drawn and the ability to attach the center of it very easily. Moving on, we now have circles. And of course, pretty straightforward. The two different circle types that we have, center point and 3-point circle, really differ in how they're constrained. Ellipse is a bit of a different thing altogether, but I'll show you that as well. So here's center point circle, left click, mouse over the origin, left click, move my circle out, left click again, and I place my circle. Okay, so very simple. Center point in the name, of course, the first click defines the center point of the circle. Move your cursor out to define its diameter, and left click again. So the next circle type is a 3-point circle, and you may ask yourself, well, why would I use one over the other? And the primary difference is, one difference is how it's sketched, but the primary difference is that it gives you points on the circle that you can constrain to other things. So it makes it a useful tool if you're trying to create an arc transition between certain other sketch geometry or features. You can actually attach points of the circle to them. Now, 3-point circle, like the name implies, takes 3 clicks. So you're essentially defining the 3 different points on the diameter. So left click, left click, left click. And for each left click, I get a point that I can attach to other geometry. Right? So 3-point circle, the big thing here is it gives you these references that you can go and attach for other things. Okay? So 3-point circle. Next one on my list is ellipse. Now ellipse, very straightforward, very similar to a center point circle. You first left click to locate the center, move your cursor up, down, left or right to define the orientation of the ellipse, and then left click, move up or down depending on the orientation to define the height. Left click one last time, and you have your ellipse. The main difference there is, of course, that additional click to define the height of your ellipse. Okay, that is ellipse. Let's move on. The next one in my list is, of course, arcs. We have 3-point arcs, tangent arcs, and a center point arc. 3-point arc, very similar to a 3-point circle. It takes 3 clicks. So left click, and then left click to define the radius size. Okay. So very simple to do. Again, 3 clicks, 3-point arc. The next one in the list is a tangent arc. Now, the thing with a tangent arc to keep in mind is it has to be tangent to some other geometry. You can't simply select tangent arc and sketch in space. So in the name, it implies that it's a tangent with the geometry that you're attaching it to. So in this case, we'll just draw a simple line. Right. Then we'll select tangent arc. Select the end point of the line, move my cursor out, left click again, and I have my tangent arc. Okay. The key thing with a tangent arc is it creates a tangent constraint between the arc and the geometry that you're attaching it to, in this case the line. So you'll see here this tangent constraint that's created. And we're going to cover constraints in just a bit. But that's the neat thing about a tangent arc, is you don't have to manually constrain it later. All right, so the next one, actually this one I should leave the line there, is the center point arc. Now the center point arc is very useful if you know if you want to be able to constrain the arc's center point based on something else. And the example I'd like to give for this is, again, I'm just going to draw a simple line. Let's say, for instance, I want a radius going from here to here, all the way around. That's an easy one for a center point arc to accomplish, right? So I use center point arc. I move my cursor up along the line until I see the midpoint right there. So as I move my cursor up, you'll see it switch right there to a midpoint, right? That's the center point of the arc. Left click, move up, define the top, left click, define the bottom, left click, and now I have an arc. And the neat thing about that is the center point of that arc is now attached to the midpoint of that line. Right, so that's the neat thing. That would be something I'd have to go in and do myself later on with a different arc type. So center point arc, very useful if you need to attach the center of the arc to some other sketch entity and constrain it. Okay, so that is the center point arc. Now we have two different types of polygons, and really the main difference between them is how how they're defined in size. So you have an inscribed or circumscribed polygon type, and that really just depends how do you like to dimension your polygons. So I'm going to show you both, but again, they're very similar. So we'll select inscribed polygon. Now it's drawn initially very similar to a circle. So I left click the center where I want the center of the polygon to be, move my cursor out, right, to define its size. But here's the important step. So as I left click a second time, I have to define the number of sides to the polygon. And this is something that's easy to miss. You want to move your cursor in or out to define the number of sides to the polygon. Right? So I can go all the way down to a triangle, or out to who knows what for a number of sides. But it's important to point out that it's tracking the motion of your cursor. So as you move away from it, it increases. As you move towards it, it decreases the number of sides. Right? So that's the last step. You define the number of sides, left click, and you have your polygon. Okay, so there is a third step to that process. It's easy to miss. Make sure to move your cursor in or out to define the number of sides you want in your polygon. Now, I mentioned before we have two different types, and again, the only real difference you may have noticed in that previous one that I had an inscribed circle. The construction circle was on the inside of the polygon. With a circumscribed polygon, the only real difference is that the circle that constructs the polygon is on the outside. Right, so again, left click, I'll move out. Let's define 8 sides, left click, and there's my polygon. The main difference between the two is this construction circle, and it all depends how you like to define the size of your polygon. Okay, do you want it on the inside or on the outside? Inscribed versus circumscribed. Okay, so moving on. Splines. Now, splines have a very specific, very unique scenario. If I wanted shapes that I can't easily create with lines and arcs and ellipses and all the tools that I've shown you so far, splines are kind of the go-to tool. Now, it's important to keep in mind, splines are free-flowing entities. They're not often not constrained or defined very specifically, and they have a lot of flexibility in how they behave, but they give you a shape that can be very, very useful, especially if you're creating shapes where you're really concerned about curvature or ergonomics, those kinds of things. Splines become very helpful sketch tools. Now, the thing to keep in mind with splines is, you'll want, if you've never touched one before, you'll want to spend a bit of time getting used to it. It's not something that's like any of the other sketch tools that we have. Everything else is very rigid and defined by constraints. This is a free-flowing thing. Right? So I select spline. Now I left click to start my spline. Now at first, when I start moving my cursor, initially it looks like a line. And as I move my cursor out and I left click again, it isn't until that second left click that you start to see a different behavior. As I move the cursor around, you'll see that the line bends, right? It's a free-flowing entity. Now, some tips about splines in general. The fewer points that your spline has, the smoother in general that it will be. So if you start sketching a whole bunch of points in your spline, it's not going to be a very smooth contour if that's what you're concerned with. So the fewest number of points that you have, the better. The smoother the contour will be. Okay. Now, I select as many points as you'd like. So I left click to start, left click for each point, left click to end it, and then you, of course, escape out when you're done. Now, you're not stuck, so to speak, with the shape that you're initially left. So if for whatever reason, let's say, for instance, this point was a little too high, you can left click and drag these points, and you can drag the handles at the ends of the splines. Okay, so these are there to manipulate and get the contour very close to what you're trying to achieve. Get it exactly what you're trying to accomplish. It will take a little bit of manipulation and time. You'll want to tweak these, and you can constrain these. You can attach these points to other entities, so they are referenceable in different relations as well. Now, I mentioned before, the fewer points you have, the better. Sometimes, just a 2-point spline with defining the ends is more than enough. Multiple point splines, the more points, the more difficult it is to maintain and to keep it smooth. So that's splines. Now, you can also add spline points. So let's say, for instance, I wanted an additional point of control here. I want to be able to grab this and pull this out, for example. I have no spline point there to grab and drag. You can insert more spline points. So just underneath spline, you'll see spline point. You can left click where you'd like to place the point, and then you have an additional point now to move or pull and control the shape. So you can insert more points if you'd like. So that is spline. Again, just in general, a tip with spline is just to spend a bit of time with it to get a feel for how it works. And the fewer points you have, the better. Often the smoother the shape will be, the easier it is to maintain and to have it look correct and to update if changes happen. So the next one on my list is a point. Now, a point you can think of as kind of a useful tool in a number of situations. It's kind of a construction geometry or construction reference to a certain degree, but it's useful in a number of situations where you need to reference a random spot on a circle or a line, maybe the midpoint of a line or the horizontal reference to the outside edge of a circle, for example. There's all kinds of examples I could give you. The simplest example is just a line. So let's say, for example, I draw a line and I need to now attach something else. Maybe it's another line to the midpoint of this line, right? I can sketch a point, move my cursor over the line until I hit the midpoint. There it is. Left click, and now I have an entity that I can reference for constraint or just, to attach to the origin, let's say, and I get that midpoint behavior. Okay. So in this case, I just use the point as a reference to attach a constraint. That's often where points are very valuable. You need to attach them as to then go in and maybe dimension or constrain the geometry that you're trying to sketch. So points, I like to think of them as construction. They just allow you to attach things as references and use them as dimension points or constraint points. So that is a simple point. Again, you can use it in a number of different examples. The next one is text. And text is very simple to do. And the key thing with text is it's all defined by the rectangle that you sketch. So while in a sketch, I select text, I draw a rectangle. It's very similar to the corner rectangle I showed you a moment ago. Left click. As soon as you left click to define the rectangle size, you're going to see a box that pops up. Here you can type in the text that you'd like. Okay, so type in the text, define the font types. Now the font types are freely available fonts that you'll find and are accessible from any computer. So we try and be open with the font types. And we also have bold and italic options as well. Green check to accept, and of course it fills the box with text. So very simple command. The key thing to keep in mind with text is really everything's defined by the rectangle, right? If you want to constrain the text, you constrain the rectangle. If you want to define the size of the text, you define the size of the rectangle. And then it's just a matter of attaching it. You can extrude, cut, revolve, whatever it is you're trying to do with text, you can do it here. Okay, moving on. So that's text. The next one on my list is use, and we have a number of different examples I could give you for use and intersection along the same lines. The use command is a very powerful one. So let's just sketch some basic geometry here. So I'm going to sketch a rectangle, and let's sketch a small circle in the middle. Okay. So I've sketched a rectangle, a small circle. I'm going to do a very basic extrude, green check. So now I have a feature. Okay, so now we've left the sketch, we've created our first extrude. What I'd like to do is create another round boss, the same diameter as this hole, and extrude up with an offset, right? Now there's a few ways that I can do this. Now I mentioned before, one of the first steps, of course, is starting the sketch. And in this case, I don't want to use one of the default planes. I want to use this face of my part. So remember before I was telling you, choose the front, top, or right. Once you have faces in your planar faces in your part, you can select them as references for sketch planes, right? So I left click the face, I select sketch, again, right click, view normal to sketch plane, and now I'm in a sketch on that face, ready to start sketching. Now, some things to point out is, initially, at least for the new user, the instinct is to sketch another circle. I want an offset, I want to sketch a circle like this that's the same diameter, and then another one out here for the offset. And then I add another dimension, define it the same way, right? The problem with that is how it updates, and this is something that you'll realize as you start getting more into it. When you make a change to one feature, if it's not tied to the others, if you have a whole series of redundant dimensions, then it doesn't update well. You'll need to go through multiple sketches to get it correct. So the benefit, or the reason I'm bringing this up, is the use command. The benefit of the use command is it converts edges, faces from other features to the current sketch. And the benefit of this is if I change the diameter of this circle, anything referencing it would update. So if I convert it using use, it would automatically update, right? So let me show you what I mean. I'll select use. I'll select the circular edge. And if you'll notice, let me rotate a bit here and hide the part. Notice that there's now a circle there. Right, that circle was created solely by the use command. It was converted from the edge of the previous feature. Okay. So now I have something that's referencing the feature from before it. I want to create an offset of it. And again, this is another scenario where I won't use a circle, but I'll actually use our offset tool. So I'll select offset, select the circle. I can drag out to define the distance. Left click and define the actual value. Let's say 7.75. Okay, so 3/4 inch offset. The neat thing about the offset is, again, it's driven by the first circle. So all of this will update if I change the original feature. Okay. So now I can do my extrude, okay, and I have my offset. Simple offset around that hole. Now the main test of this is, of course, because of the way I built it, I should be able to go back to the first feature, change the diameter, let's make it a bit bigger, and have everything automatically update. So notice this extrude automatically grew as well. If I had defined that using dimensions, then that doesn't happen, and I have to go back and define, actually have to edit the sketch, change the dimensions to match it. So the use command in general is a very powerful tool. I highly recommend, if there's any situation where you can constrain it to a previous feature, oftentimes there's a benefit from doing that. It's a much faster change. When you make a design change, everything rebuilds as opposed to having to go through each feature manually. So just a tip on use in general. Okay, so moving on. Now, one thing we haven't covered up to this point is construction geometry, and it's worth pointing out that we do have a separate command for construction, and any one of our sketch tools can be converted to sketch geometry. Now, I can select a tool, for instance, line, and then select construction, and then draw my line, and I get a construction line. Okay. Same thing goes, by the way, for a circle, construction, I get a construction circle. Okay. So you can select the tool, then select construction, and then select, draw the actual entity, and it becomes construction geometry. What you can also do is select the entity and then select construction. So if you've already sketched it and you want to convert it to construction, you can do that. Just left click, select construction from the toolbar, and you have it. All right, so moving on. The next one on my list is Sketch Fillet. Now, Sketch Fillet, very simple, and we have, of course, the feature level fillet. This allows you to do a very simple thing, similar thing, just radius, a sharp corner with an arc. Very simple tool to use. There is some neat things built into this. Let me show you it. I'll select Sketch Fillet, and at first, you'll select a point, for instance. Select the radius size. Let's make it 0.5, and you have your fillet. And the neat thing about Sketch Fillet is if I go and select another point, it automatically assumes that I want the 0.5 that I punched in from the last time. So I can go and now select as many points as I want, and they all get radiused at the same size. And they're even constrained to each other. What's also neat about this tool is, let's say, for instance, I don't know exactly the size that I want, but I know, just eyeballing it, I want to move it to a certain amount, is you can actually left click and drag and dynamically resize the sketch fillet. So if instead of just left clicking a point, if you left click drag a point, you'll get this dynamic resizing sketch fillet, and you can get it, something right about there, let go, and then you'll get, okay, that's roughly a 4-inch radius. So it's a neat way if you want to resize the fillet dynamically. Instead of just left clicking a point, left click and drag a point. That left click drag logic, by the way, goes to more than just the fillet. I showed you a moment ago the offset tool. The offset, if you left click and drag, instead of offsetting a single entity, it offsets the chain of sketch entities. And so if I select offset, for example, here, and I just left click a line, I get an offset of just that one line, right? So I get just the one line being offset. However, if I left click and drag the line, I get the offset of the entire chain of sketch entities. Right? So just a subtle thing, but it's very easy to offset the entire chain of sketch entities with a left click drag instead of going around and left clicking all the individual sketch entities to offset them. So just another example where the left click drag makes a difference versus just single left clicking. All right, so there are a few tools that I want to point out, but I'd like to get into dimensions and relations and actually constraining all of this. So we've covered a majority of the sketch tools that are available, but how do we start constraining and defining all of this? So right now we have no idea what the size of any of this is. So let's go back and just draw a simple rectangle. We'll start basic. Some things I want to point out is, as I mentioned early on, a sketch is constrained or defined with a combination of dimensions and constraints. It's worth pointing out that a lot of constraints in Onshape are created automatically. So a lot of what's going on with constraining and defining the relations, it happens automatically. You don't really have to be aware of it. But you can see it. If you check Show Constraints in the sketch dialog, you'll see these little white flags appear. In the case of a rectangle, you'll see a lot of them. You'll see things like coincident and midpoint, perpendicular and parallel, and these are what construct the center rectangle in this case. So you do see the constraints. You can turn them on if you choose to, and you can left click and delete to delete individual constraints. So that's another question that comes up. How do I delete them if it's overdefined, or if I created one on accident? left click, and then hit the delete key. You can also see the constraints by just mousing over the geometry. So if you move your cursor over the geometry, even with the show constraints off, you'll see these icons appear just for whatever it is you're moving your cursor over. So they kind of dynamically appear and they'll disappear based on where your cursor's movement is. Just a tip, if you're struggling to select one of these constraints, you can hold down the shift key and that will lock them on the screen. So if you ever moved your cursor over and then you move it and it disappears and you can't understand why, I can't get to that thing, just hold the shift key down and it locks those constraints on the screen. Okay, so that's constraints. Now I'm going to go over in a minute how to manually add constraints, but just understand that at first, a lot of your constraints are going to be automatically created. Now, what about the size? How do I define the dimensions? Right now, I have no idea, what size this rectangle is. If it's several inches, several feet, I really don't know. And so dimensions are the other important aspect of defining your sketch, right? We have constraints and we have dimensions. Now, dimensions are, of course, how we define the size. So I select dimension from the toolbar. Now, there's a few ways that you can define dimensions. So it's worth pointing out that you have options, and in many situations, they give you the same end result. So if, for instance, I wanted the width of this rectangle, I could select this line, and create a dimension. I could select the point and get a dimension, or I could select just this line and get a dimension. So just understand that with dimensions, you have options. You could argue one's a little bit faster than the others, but it's important to point out it doesn't matter. It gives you the same end result. Now, in this case, if I select a line, just left click, move my cursor up, an important step, move the dimension away from the sketch geometry, then left click again to place the dimension. You'll see a little window appears. You punch in a size, 1/12. Okay. So now the entire sketch scales to that first dimension. Right, so you'll see everything kind of zooms out just a bit. The entire sketch scaled to that first dimension, but now the width of this is actually defined by a dimension. The key thing I want to point out here is notice these two lines are now black. Right, a moment ago, those were blue. And so you're getting visual feedback as to the level of definition that you have. Your goal with every sketch should be to have a fully defined sketch. Right, now, it's not a requirement. It's more of a best practice. But it should be a goal. And the idea is, having the entire sketch fully defined makes, simple changes going forward easier, and it makes mistakes less likely. It's very easy with an undefined feature to make a change and have it impact something that you weren't expecting. And if it's not defined and things shift, it may cause a problem. So fully defined features in general, just a best practice. And so you get that visual cue that these lines, the width of them is defined, but the height is not defined, right? That's something that I'm missing here. These points are not, right? The height of this rectangle is not defined. So just some things to keep in mind. You do need some level of dimensions to your features, and you really want everything fully defined, right? So we'll do this one more time. Dimension. By the way, D key from the keyboard, if you like keyboard shortcuts. Left click. I'll enter, let's say 9, enter, and notice now my entire sketch is fully defined. Right, so everything is black, and that really should be the goal. But the key thing there is you're getting that visual feedback. If I were to go in and start sketching more entities, I'd need to add more constraints or dimensions to make sure they're correctly defined or correctly constrained. Okay, so that is dimensions. Now, it doesn't matter really the dimension type. The steps are the same. It's a left click on the entity, left click where you want to place the dimension. So let's take that one step further. I'm going to draw 2 circles. Start at the origin, a circle here. We'll draw a circle here. And what I'd like to do is draw a line that joins them. So line here. Notice that as I move my cursor, it attaches to the right circle. So you'll see it attached there. And if I move it up along the circle, it'll even become tangent. Right? So I can get both coincident and tangent constraints, both constraints at once. Left click. I'll escape out of the next line. We'll do one more on the bottom side. Same thing. I'm going to move it around till it's tangent. There we go. Notice that the entire inside of this contour is shaded a slightly darker color than the outside of the graphics. And the idea there is in Onshape, we visually give you that cue that this is a closed contour. You don't have to hunt whether this point is connected to this circle. If it's closed, it will shade in a different color. So the idea is they're just kind of the instant visual indication that I can use this for an extrude or revolve or whatever my goal is. So I have these shapes in place. Of course, the next step is adding dimensions. So we'll add dimension, no different than the rectangles that I was dimensioning a second ago. I want to define the size of this circle. Left click. Let's say it's 1. Notice the entire sketch scales. So initially my circle was much bigger than the finished size. So when I enter 1, the entire thing scales. We'll zoom in here, punch in a value here, left click, 0.625, enter. Now I want to define the distance between these circles. Now I can left click the center points of the circles, or I can left click the outside of the circles. And it really depends what dimension do you want to control. If I care about the overall length of this part, then the outside of the circle to the outside of the circle makes the most sense. If I care more about the center point to center point distance, I may add that dimension instead. But again, left click, and then move your cursor out, left click one last time, and enter the value. Now notice that although my circles are fully defined, they're both black, the lines are not, right? And so I can go through and see all the different constraints associated. I see I have a tangent constraint here, but I don't have, if you look closely, a tangent constraint over here, right? I don't have a tangent constraint attaching this circle to this line. So there will be situations where you need to manually add constraints. So I'd like to walk you through that process. So let's say again, I want to make this line tangent with this circle. I just left click the circle, then the line, then select tangent. Okay. Now it doesn't matter what the constraint is. The constraints are all here on the far right end of the sketch toolbar, but the process is the same. Left click the entities, left click the constraint type. Okay. So let me show you another example of that. Let's sketch 2 circles, and I'm going to deliberately sketch these circles just out here in space. Okay. So just 2 circles out in space, and what I'd like to do is make these circles concentric with these, and then also make them the same diameter so that I can add a dimension to one and both change. So I'm going to walk you through manually creating the constraints necessary to do this. So the first thing, I want to make them the same diameter. Left click, and then I'll set them to equal. Okay, equal constraint. Now when you change one, both update. Okay, and again, just select the 2, select the constraint. Now I want to center these circles concentric with these that we sketched earlier. Again, left click, select concentric. Okay? Left click, concentric. The last thing I need to do to fully define this is add a dimension to define the size of the circle. Okay. So again, there will be situations where you need to add your own constraints. You need to walk through, adding your own constraint types, and it really just depends the situation that you're in. But the steps are the same. Select the entities, just left click them. It doesn't matter, you can have 10 circles there and you want them all the same diameter. Just left click all of them or window select them, and then set your constraint. Select your constraint type. Again, make sure that if you want to see the constraints or if you want to delete one, you can check Show Constraints. It will turn on a bunch of little white flags that allow you to select the constraint and even delete it if you choose to. Okay, so that is a large part of what I wanted to cover here today. I really have one last thing that I wanted to mention, and that is planes, custom planes. Now, I mentioned before you can use any planar face, right? So let's just take my previous sketch here and extrude it. If I have a simple flat face, for instance, I can use that and start a new sketch. I can use any one of the default planes, the top, front, or right planes to start a sketch. But you can also insert your own custom planes. And it's a very useful tool if you need to insert a plane at a certain point where you either don't have a planar face or you don't have a default plane. You'll need to insert one. So the command to create a plane, you'll need to be important thing. You'll need to be out of a sketch. It seems obvious, but make sure that you're not in a sketch. Select plane, and you can use a number of different plane options. We have simple offsets. We have a plane and another point that I can reference. Line angle, point normal. I'll go through a few examples of these. But the simple example is an offset. So let's say, for instance, I wanted a plane an inch off the end of this part. I could use the end face of the part as a reference, and you'll see it inserts a plane 6 inches away from that face that I use as my reference. So here's the 6 inch. Let's set this to maybe 4, and you'll see it shift. And so all I'm really doing here is giving myself a sketch plane that I can start working on that, again, I don't have a flat face or a default plane to use. So offset is the simple one. Another one that's very common is like a plane point, for example. So I can go plane point, and I can reference, let's say, the right plane and a point on the model. And it'll actually put a plane parallel to the one you've selected at that point. Right, so there I'm referencing a point on the part. So a lot of different plane examples I could give you. Another one that's very common would be a curve point. The end of a curve. So for instance, sweeps. Very common that you sweep a profile along a path. You'll need a plane at the end of your path to attach your profile. Curve point is a way to accomplish that. Another common one is a line angle. If you need to rotate, if you want to create a plane at an angle, you can do that by rotating based on a reference angle or a line. So lots of different options for plane types. I'm not going to get into each one specifically here today, but definitely useful as you start getting into more elaborate shapes. You'll need to insert or create your own planes. A question that's come up concerning dimensions. Can two objects increase, decrease in size by dimensioning being linked to both objects? Absolutely. What you can do and what I'd look into, I didn't cover it in this beginner's sketching, but I would look into variables. So I could create a variable, for instance, called bore, and set it equal to a value. I'm just making this up as we go along here. But this variable now I can assign any dimension to, and I can multiply even. I can say that this is equal to 2 times the bore, and this one's equal to 1/3 of the bore. So the neat thing about this is you can then use those values instead of the actual dimension. And the neat thing is now I can tie 2 or 3 things to this. I can tie 10 dimensions to this one variable and change it in one place. So variables would be the thing that I would look into because they allow you to change things on the fly. Right? So now I'm controlling the inside of that circle diameter with a variable. And I can control multiple parts with it. I can do all kinds of neat stuff. Even do equations and multiply, this times the variable or half the variable or all kinds of cool stuff. So, all right. So that is what I had planned for you today. I'm going to stick around and answer any questions. So feel free to type them into the questions dialog in your GoToWebinar panel. I do have one last thing that I want to point out for those just getting started. If you're just getting into Onshape, we really encourage you to try Onshape in your professional environment. Let us know what you think. Especially if you've got a real task that you're trying to accomplish, and we want to know what tools do you need, what kind of functionality is it that you need to get this job done. So definitely let us know what you think. If you haven't shared your document, this is another one that I definitely recommend. In the top right, you have share, and you can type in their email address, enter the permissions that you want to give them. So you can give them view only permissions or the ability to edit, depending on how much you trust them, and then hit share. And that's it. Even if they don't have an Onshape account, we create one on the fly and then send them a link. So, feel free to share. It's very easy. They just click a link and they're looking at the same document you are. You can even work together in real time. You can comment. There's all kinds of neat stuff that goes along with sharing your document. Okay, that is what I had planned. I want to say thank you everyone for coming. I'm going to stick around and answer any last questions, but that's it. Thank you everyone.